All right, so now we came to the last thing, which is basically obtaining the equation of a sine or cosine function given a graph. So sometimes I will give you a graph and then you have to come up with the equation, which can be a little challenging. So here are some ways that you can kind of try to figure it out. So first, one of the good things to do is to be able to find the midline. So the midline in this case would be what is the halfway point where you can divide the graph in half. So the midline here would be the halfway point. So you can see here it's halfway. So it kind of divides the amplitude from the top and the bottom. So from here to here, and then from here to here is basically half of it. Okay, so this midline, if you locate it, that's the value of d immediately. So remember, my function is going to look something like y equals a sine b x minus c plus d. Well, once I find the middle line, I already got the first thing, okay? Notice that once I have my d, I can easily figure out my a because I know that it's either going to be, you can find how far it is from the midline up, or you can find how far it is from here to here, okay? And then just kind of figure out the distance from there to there. So you can also figure out the a value. This part is the one that's a pain in the butt. Okay, so this guy is really going to give us a lot of trouble because there's a lot of cool things that you got to do. So when you're looking at this middle part, one of the things that I would suggest is to be able to, oops, what the heck? I didn't want that. So did I do it? Yeah, okay. So one of the things that you want to be able to do is take a part of one period of the graph. So you're going to take one part of the period of the graph and then use it combining with 2 pi over b to figure out the period, because you'll know what the period is. And then notice if there's any phase shifts, okay, from that point. So it's a lot of work, especially this green part. D and A are pretty easy, but we can try to do it. So let's go ahead and take a look at this example. So locating the midline can give you a lot of information. So you can see that the midline here is at y equals 1. You can see that the amplitude is going to be 3 because you can see that from 1 to 4 is just going to be 3. It also tells you the period, right? So the period is where it starts repeating. So you can see for that from here all the way to here, it completes one cycle, and you can just easily subtract pi minus 0. That's pi. So that's going to give you the period itself. So can you try to guess what the equation of the curve will look like? Well, let's take a look at it. This is a sine curve, right? So it's going to look something like this. Y equals a sine of b x minus c plus d. We know what d is, right? D is just going to be whatever the midline was, which is equal to 1. So it's going to be positive 1. We know what the amplitude is. In this case, it's going to be equal to 3 because you go up 3 units. Now b is a little tough because we need to know what the period is. We know that the period is equal to 2 pi over b. We don't know what b is, but we know that the whole period is pi. So the period is pi. So we can move the b over. So we get b times pi equals 2 pi. Divide by pi. You get that b equals 2. So now we know what b is. Okay? And now what about c? Well, let's think about it. The sine curve usually starts at 0, 0, right? Usually starts here. It doesn't seem that it moved anywhere. It seems that it stayed in the same place. It just got shifted up. So that means c in this case, there's no phase shift. It didn't move at all. So my whole graph would be, or my whole equation would be 3 sine of 2x, the c goes away, plus d, which is plus 1. Okay? Now, one of the things to remember is that the graphs are not unique. Or I'm sorry, the equations are not unique. And what that means is that someone can figure out this equation, but someone else can use a cosine curve, for example, and still yield the same equation. So that is something that's really complex. You have to be very smart about what part of the graph you want. Someone can choose one part and some other ones can choose another part. So that's one of the difficulties about this thing. But it's also the good thing because not everyone's going to have the same thing. So let's go ahead and do some examples. An example of this. So something that will be really useful as you're going in through this challenge is that you typically want to use these formulas. Okay, not the one with the bx plus c over d. I think these are a lot easier. C, I know I changed it up for you. I wrote c over b last time, but I think it's easier if you just write it like this way. C in this case is going to be the phase shift. Okay, and b here is you're going to use a 2 pi over b stuff. Okay, so let's go ahead and do this example. So determine the equation for the cosine function given the following graph. So we're going to use a cosine function to be able to find this graph. Again, you could have used anything that you wanted. You can use sine also, but I think sine will be a little complex. So we're going to use the cosine function. So we need to figure out y is equal to a cosine b x minus c plus d. All right. So first things first is to try to locate the midline. One thing that you can do is you can look at the bottom of the amplitude and the top of the amplitude, the bottom of the wave and the top of the wave, add them and divide by 2. So you can just add them if you want to. So -5 plus 1 and then divide it by 2. And this will tell you -2. So this is telling you that at -2, this guy is divided in half. You can see 1, 2, 3 down, 1, 2, 3 up. Okay, so y equals -2 is my midline. Okay, also you can just count. I don't know, whatever helps you. So this tells you that d is going to be equal to -2. So this graph was shifted down -2 units. All right. Okay, now the next thing that you want to be able to do is pick an easy enough period that will help you. Okay, I think the easy enough period would be this going from here. So let's just start from here. Right? So this is going to be like where I start. And this is going to be where I end. Right? Because that's one full cycle. I think this would be a really good, nice chunk. Of course, you can choose anything else, but the reason why I wouldn't choose anything else is if you wanted to start here, it'll be really hard because I don't know where exactly this is crossing. This one, it seems like it's going through -2. This one's going through +4. So you kind of have an idea. You're working with really nice numbers, and I think it'll be really nice. Okay, so one of the things that I noticed, first let's look at the amplitude. So how far is the wave or the midline to the highest peak? So you can see that that's just 3 units. So amplitude is 3. Now notice here though, this is a cosine curve, okay? Shouldn't the cosine, if I look at the midline, shouldn't it be on top, right? But in this case, it looked like it was flipped. So this a value should actually be -3, right? Because if you remember, the cosine curve looks up like this. And here, it looks like it's flipped, so that's why we're adding a negative next to the a. All right, so we got the d and we got the a. Now let's figure out the b part. So b is going to be what? So we know that the period is equal to 2 pi over b, absolute value of b. Just gonna write b. Now what is the period? So let's see, how far is one end to the other end? How far are they? Well, this is 4. This is -2. So 4 minus -2. So the period is how far they are. So 4 minus -2. That's 6 units. Okay, so that means the period is 6. So it completes one full cycle in 6 units. Okay, so I'm just going to plug in this 6 in here to figure out what b is. So 6 equals 2 pi over b. So 6b equals 2 pi. So b is equal to 2 pi over 3. Oops, that's wrong. pi over 3. So that's what b is. And now finally, we're going to look at the phase shift c. So remember that the phase shift is going to be how far did it shift? So notice that the cosine curve initially starts at 0. But notice that it was shifted over from a starting point. The starting point was at 0, now it's shifted over how many units? Shifted over 2 units to the left, okay? So when something is shifting over towards the left, so it's going to be 2 units to the left. That means that this guy in the inside should be a positive number, right? So I'm going to write down 2 units to the left. That's going to represent that, -2. So we're going to plug it in. So you're going to get y is equal to, we know what the amplitude is, which is -3. Then it's cosine. The b in this case is pi over 3. My x in this case is just going to be x minus -2, which is +2. So notice that this +2 just telling me that I'm moving over to the left 2 units, and then d, which is in the -2. So I can just finish this up as -3 cosine pi over 3x plus 2 pi over 3 minus 2. And this would be my final solution. Okay, now again, like I was saying before, you don't necessarily have to do it this way. You could have done it a different way. And notice that these guys are not going to be unique. They're not exactly going to be just the same exact graph. Okay, I'm sorry, the same exact equation. You could have picked another point, any 2 points, and just try to figure out another way to do it. Okay, so again, this is just one way to do this problem. It does take a little bit of time, especially the inside portion, but this is how you would tackle something like this.